All right. Hello, everyone. Assalamu alaikum. Let's begin then. So, in the last session, we did probability. We covered the concepts that we have in probability. Apart from conditional probability, that's what we will be doing today. And then, in addition to that, we will be doing some past paper questions on probability as well. So, that's the plan for today. We'll just want to do some practice questions on probability and also cover the last concept that we are left with in this topic, conditional probability. So, what did we start with? We said probability is basically the chance of something happening. When we talk about percentages, if we write that same number as a decimal or a fraction, that number is generally between 0 and 1. In fact, always between 0 and 1. We say that this is probability. 0 probability means that something is impossible. 1 means that it is absolutely certain to happen. This is the formula that we use for probability. Number of favorable outcomes divided by the total number of possible outcomes. That's the formula for, that we generally use to find probability. We looked at some examples of this. Let's say if I toss a fair coin, what's the probability of getting ahead, and so on. We looked at a number of different cases like this. There were two representations that we also talked about. One was this diagram that we call the possibility diagram, in which we draw a table to represent all the outcomes. It's a two-dimensional table. On one axis, you have one event, one set of outcomes. On the other axis, you have the other set of outcomes. And then using this table, we find the probabilities because we have all the outcomes listed down in this table. Sometimes we make an addition table, or sometimes we have a multiplication table, difference table. We looked at different examples of that in the last session as well. Then we talked about tree diagrams. So how do tree diagrams look like? They have a structure like this. There are different points out of which we have different branches emerging. There are two cases that we generally have to deal with in problems like these with respect to if you're taking an object out of anywhere. It could either be with replacement or without replacement. With replacement means that every time you take out something, you put it back before taking out the next object. In that case, the probabilities every single time remain the same. For example, probability of taking out a red ball, that remains the same both times in this case. But then the other case was when you are taking out something without replacement. So you take out one thing and then you take out another thing after that. For instance, this was one. In this case, what happens is the total number, the denominator, this keeps changing every single time. Okay, so the first time you do something, the first time you take something out, you do not put that back before taking out another thing. And then because of that, what happens is the denominator keeps reducing every time. And the numerator also, based on what you're taking out, it keeps changing. We talked about this yesterday, the difference between with replacement and without replacement cases. We talked about the tree diagram, how to draw the tree diagram, and how to calculate probabilities from that. These were important points to remember when we calculate probabilities using tree diagrams. Along the branches, when we go horizontally, have to multiply probabilities, right? So when we go along the branches in this direction, we multiply probabilities because there's an and between those cases. And when we go vertically, there's an or between the cases, so we add those probabilities. From every single point, the branches that are coming out, the sum of their probabilities is always going to be 1. For example, we have this point here. There are two branches coming out of this. Their probabilities always are going to add up to 1. These probabilities, they also add up to 1. So every single point in the tree diagram, whatever is the number of branches coming out from there, the total of those probabilities is always going to be 1. Okay. This is what we talked about. And then finally, if it's with replacement that we talked about earlier, if it's with replacement, they will always tell you in the question that this is with replacement. Without replacement, they will sometimes tell you that it is without replacement. If they don't say anything, if the question is silent about it, you assume that this is without replacement. So unless they specify anything, you assume that it is without replacement. So in a tree diagram, the next nodes, the next branches, they're going to have lower probabilities as compared to the first time. Okay, so that's what we did during the last session. We did some practice questions as well. Now, the first thing that I want to do today is understand the idea of conditional probability, first of all. Now, this is part of the IGCSE math syllabus, but it's not part of the O-level math syllabus. Okay, so this particular concept, conditional probability. So if you're from O-levels, you can skip this part. If you're from IGCSE, you need to know this as well. Okay. Now, what is conditional probability? Let's try to understand this. Let's take a very simple example of this first. Let's say you roll a dice. Let's say you roll a dice. What is the probability? What is the probability of getting, let's say, a 3, right? So you roll a dice. What's the probability of getting a 3 when you do that? Okay, so what is the probability of getting a 3? It's a fair dice. There are 6 possible outcomes on a fair dice. Probability of getting a 3 is going to be 1 out of 6, right? So that's really straightforward. One outcome is 3, and the total number of possible outcomes is 6. So the probability is there for 1 out of 6. Okay, but now, if I were to change this slightly, and instead of finding the probability of getting a 3 as it is, what if there was an additional condition added there like this? So you roll a fair dice. Okay. Now, given that the number you get is an odd number, what is the probability that it is a 3? So in the first case, we did not have any condition given. We were just asked, what is the probability of getting a 3? And we said that is 1 out of 6. But now we have a condition given, and the condition is given that. So generally, this is the keyword that you would see in conditional probability, given something. So they're saying, given that the number that you get is an odd number. So we know that the number that we get is an odd number. What's the probability that it is a 3? Now think about this. In the first example, 1, 2, 3, 4, 5, 6, all of these outcomes were possible, right? We could have any one of these 6 outcomes. Out of them, 3 was one outcome, so that we said that is 1 over 6. The probability should be 1 over 6. But now in the second example, if you look at this now, it says, given that the number that you get is an odd number. So now, from this set of outcomes, 1, 2, 3, 4, 5, 6, all of them are not possible outcomes, right? You're rolling a dice, but now we have reduced the possible outcomes because they have told us, they've given us additional information that the number is an odd number. So the only possible outcomes that you can have now are these 3, 1, 3, and 5. So when you use the probability formula now, remember what the probability formula was? It was the number of favorable outcomes divided by the number of possible outcomes. Now, the number of favorable outcomes is still 1. That's 3. That's going to be your numerator now, which is 1. In the denominator, instead of having 6 now, you have 3, because only these 3 outcomes are possible, because they're saying it is an odd number. It is given. It's given that it is an odd number. So it can only be 1, 3, or 5. So what's the total number of possible outcomes in this case? That's just 3. We say that the probability in this case is 1 out of 3. This type of probability is known as conditional probability. So we have a condition given, and using that condition, we have to find some probability. Okay, this is conditional probability. Make sense? So in this case, what happens is the total possible outcomes, that number changes. So it's not 6 anymore, it reduces to 3 in this case. Okay. So the formula for conditional probability is going to look like this. You will study this in more detail in A-levels later on. For now, you can think of it like this. Conditional probability, it's going to be like this. In the denominator, you would have the case that is given, probability of what is given, or the number of possible outcomes for whatever is given. So in the denominator, you need to have what is given. Okay, what's given? It's an odd number. That's what you need to have in the denominator. Okay, in the numerator, you have the probability of both things happening at the same time. Both conditions being true together. So what does that mean? In the denominator, you have what is given. What is given in this case? Odd number. How many odd numbers do we have here? That's 3. In the numerator, both conditions should be true. With both conditions, it should be an odd number and it should be a 3. How many possible outcomes do we have there? It's 1. So that's what your numerator is going to be. Now we can think of it in terms of probability as well. That's what you generally have in the formula when you do it later on. So in terms of probability, it would look something like this. Both conditions being true. So in this case, odd number and a 3. So that probability is going to be 1 out of 6, right? If the total possibilities was 6. In the denominator, probability of what is given, probability of getting an odd number when we roll a dice, that is 3 out of 6. And that gives us 1 out of 3 because 6 and 6, they get cancelled. Now, for the question that you would get, it's going to be simpler than this, that you can just count the number of possibilities, just put that number in the numerator, the number satisfying both condition, or let me make it simpler for you. So you can say the number of outcomes where both conditions are met. Let me write it like this way. Outcomes where both conditions are met. And in the denominator, you have outcomes satisfying the given condition. So in the denominator, you have what is given. In the numerator, you have both conditions. So in this case, 1 is the number of outcomes that satisfies both conditions. 3 is the total number of outcomes in the given condition. Now, let's do some more examples on this to make it clearer. Let's say we've got something like this now. I'm going to take another example. Okay, so let's say now we are rolling 2 dice. 2 dice are rolled. And what happens is the sum of the 2 dice score is calculated as the sum of the 2 numbers obtained. Okay, so you're rolling two dice, and what you have is that the score is calculated as the sum of the two numbers that you get. Okay, and now they're asking, given that the score on at least one of the two dice is 2, find the probability that the score is 5. Okay, now let me read it out for you. Two dice are rolled. The score is calculated as the sum of the two numbers obtained. Okay. Given that the score or the number on one of the two dice, given that the number on at least one of the two dice is 2, find the probability that the score is 5. Now, how do we think about this? We're talking about adding the scores on the two dice, right? So we can use a possibility diagram for this to make it simpler to understand. So we have two things happening at the same time. We can draw a possibility diagram, the 2D table. That would look like this. We have an addition table. On one axis, we can represent numbers from one dice. On the other axis, we can represent numbers from the other dice. So let's draw these two axes like this. So we have 1, 2, 3, 4, 5, 6. And similarly, on the vertical axis, we have 1, 2, 3, 4, 5, 6. Okay, so we have these numbers on both axes. One of them represents one dice, the other represents the other dice. And then we have this table filled like this: 2, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 8. So we're just adding the two numbers in this table, right? So 4, 5, 6, 7, 5, 6, 7, 8, 6, 7, 8, 9. And then what are we concerned with? Then we can have the other numbers here as well, because they're not going to be relevant for us, because we're just talking about the score being 5 and the number on at least one of the two dice being 2. So we can skip the rest of it. The total outcomes is 36. Okay. But now, how are we going to calculate the probability? Remember what I said. The probability is going to be that in the denominator, we have the number of outcomes that satisfy the given condition. What's the given condition? At least one of the two dice, should show 2. Number on at least one of the two dice, it has to be 2. Now, how many outcomes are these? For at least one of the two dice is showing a 2. There are these outcomes and these outcomes. These, right? In these cases, either one number is 2 or the other number is 2. What's this total number? This total number is 11, right? You can count them: 6 here, and then 1, and then 4, 5 here. That's 11. The denominator here is going to be 11. That is given, the number of outcomes for the given condition. All right. What probability are we looking for that the score is 5? Now, out of these 11 outcomes, how many are 5s? Out of these 11 outcomes, how many are giving you a score of 5? 1, 2. So the numerator, therefore, is going to be 2. So the probability is 2 out of 11. That is what we were looking for here. Okay, that's how conditional probability works. Any questions on this? Does this make sense? Okay, this is the trickier part of probability. Conditional probability. Let me know if there are any problems with this. No questions? Okay, let's have a look at another. So now let's say we've got this example. Sachin picks a number at random from the first three multiples of 3. He then picks a number at random from the first three prime numbers. He adds the two numbers to find a score. We have to complete this table. Okay, let's think about this now. So number is picked at random from the first three multiples of 3. On this axis, they have multiples of 3. So the first number is 3. And then they have left it blank. What should this be? It should be 6, right? Let's fill this number. And then he then picks a number at random for the first number. So first prime number is 2. The second is 3. What should the next be? 5. Okay. Now he adds the two numbers to find a score. Now we have to add these numbers. Okay. Now this part is going to give you the outcomes when you add those two numbers. Let's see what we get from that. 3 plus 5 is 8, 6 plus 2 is 8, 6 plus 3 is 9, and 6 plus 5 is 11, 9 plus 3, 12, 9 plus 5, 14. So you've completed this table. Okay. Now they're saying, given that the score is even. So what is given? Given is that the score is even. That should be your denominator. How many even numbers do you see here? In the outcomes, remember, outcomes are only this part. Okay. How many even numbers do you see there? There's 8, there is 6, there's 12, 14, and 8. How many are these numbers? These are 5 numbers in total. So that is going to be your denominator here, 5. Out of these 5 numbers, we need to find the probability that one of the numbers he picks is 9. So out of these 5 numbers, do you see any 9 there? So be careful about this. They're saying score is even. So this part here, this represents the scores. But what they're asking about is, find the probability that one of the numbers he picks is 9. The numbers that he's picking are these numbers, 369 and 235. When is he picking a number 9? Which case is that this is when he picks up a 9. Out of these 5 outcomes, that is possible when he gets 12 or a 14. In case of 12 and 14, one of these numbers is 9. So out of those 5 outcomes, how many satisfy the condition? 2 satisfy the condition. They satisfy both conditions. The score is even, and one of the numbers that is picking is 9. These are 2 outcomes. That's going to be the numerator here. So the probability, therefore, is 2 over 5. And that is what we were looking for here. Is that all right? Make sense? Okay. All right, good. So that's how conditional probability works. Now let's have a look at some more practice questions, not just in conditional probability now, but overall. And what I'll do is I will add some conditional probability parts to it. So sometimes it can be asked about conditional probability from tree diagrams as well. So what I'll do is I'll have a look at a couple of questions and I'll add a few parts to them that test conditional probability as well. Okay, so let's think about this example now. So we could be asked about conditional probability from a tree diagram as well. Now let's look at this problem, and then we'll see what conditional probability question you might be asked in this case. A bag contains 12 discs. There are 8 blue and 4 red discs. A disc is picked out at random and not replaced. Okay, so this is without replacement, right? A second disc is then picked out at random and not replaced. The tree diagram below shows the possible outcomes and one of their probabilities. This is 3 out of 11. We need to complete the tree diagram. Okay, so we have 12 discs in total initially. Out of them, 8 are blue and 4 are red. So what's the probability of getting a blue disc the first time? It's 8 out of 12. Leave it in this form. Otherwise, calculating the next probabilities is going to be tedious. If you simplify it as 2/3, then the next probability will be more difficult to calculate. So what you'll do is on the tree diagram, you will leave the probabilities in unsimplified form. That makes things easier. 8/12, and then for the red disk, the probability is 4 out of 12. Now, once you take a blue disk out the first time, what's the number of disks left in that bag? You have 7 blue disks left now and 4 red disks left now. What's the probability of getting a blue disk the next time? It's going to be 7 out of 11. And a red disk, the number of red disks is still 4. So that is going to be 4 out of 11. When you take a red ball the first time, red disk the first time, what's the number of disks left after that? You have 8 blue. And since you've taken out a red disk, you have 3 red disks left after that. 8 blue and 3 red. So what's the probability of getting a blue disk the next time? It's going to be 8 out of 11. And this is already 3 out of 11. They've given you that probability. That's what the tree diagram is going to look like. Okay, so that's what happens in the cases where it's done without replacement. The probabilities next time, they get reduced. Now they're saying, expressing each of your answers as a fraction in its lowest terms, calculate the probability that both disks are red. Okay, now look at the tree diagram. Both disks being red, what case is that? This and this, right? In this case, both disks will be red. What do you do with this? What do we do with these probabilities? We're going horizontally. We multiply these probabilities. 4/12 and 3 out of 11. What do we get from that? 4/12 times 3/11. You can see what that is. It's going to be 12/12 times 11, which simplifies to 1/11. This is 1 out of 11. Okay, that's the result that we get from this. Then they're saying at least one disk is blue. Okay, now how do we think about this? At least one disk is blue. At least one blue means you can have one blue, you can have 2 blue as well. Which cases are those? Blue, blue, that's one possibility. You can have blue, red, and you can have red, blue. There are 3 cases that you have in which at least one of the disks is blue. One possibility is that you find each of these cases. So you find the first one, that will be 8 out of 12 times 7 out of 11. Similarly, find this one and this one. And then you add all of them up. You vertically add these probabilities. That's one idea. You'll get the correct result using that. Or another way of thinking about the same thing could be, they are saying at least one disk should be blue, right? We know that the total probability is going to be 1. The total probability in each case is 1, right? So for this whole, for all of these 4 cases that we have, blue, 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 red, red, blue, red, red, the total is supposed to be 1. If we can subtract from 1, this probability, 1 minus 1/11, that gives us 10 out of 11. The probability of both being red was 1 out of 11. In all the other 3 cases, at least one of them is blue. So what is going to be their sum? That is going to be 10/11. So you just subtract from 1 this first answer, and you would get this result directly. You would not have to calculate all of them separately. You can do that as well. You should get the same result from that as well. But this is much quicker. Since you found the probability of 2 reds already, you can subtract from 1 that probability to get the rest of them. Okay, so that's 10/11. And now they're saying a third disk is picked out at random. Calculate the probability that all 3 disks are red. So now they're taking out another red disk after this. We want to find the probability that all three are red. Now, do we have the probability of 2 being red? 4 out of 12, and then 3 out of 11. We multiply them. For the first one, 4 out of 12. For the second one, 3 out of 11. If the third is also red, what would be the probability of the third also being red? So again, you'd have two cases. One is going to be blue and the other is going to be red. What is this probability going to be? The number of red balls, the red disk the next time is going to be 2 out of how many? 10. So that's going to be the next case. You multiply these probabilities and you get the result. You can see what that is. It's going to be 2 out of 110 or 1 out of 55. You can put this on your calculator as well, because this is from the calculator paper. You can put this on your calculator. You should get 1 out of 55 from this. And that's the final answer that you were looking for here. All three are red. All right. I hope that makes sense. Now, that's what the question says. Now, let me add another part to it. So let's say they say something like this. They say, find the probability. So given that second disk, given that the second disk is red, what is the probability? What is the probability that both are red? Given that the second disk is red, what is the probability that both are red? Now we already know the probability of both being red. That's 1 out of 11, right? But what we have done now is we have added a condition here that both disks are red. That's a condition that we have. Now, when this is the condition, the probability of both being red is now going to change, right? Earlier, there was no condition. So this probability of both being red is when there's no condition there, okay? Now that we have that condition, remember how this probability is going to work. In the denominator, we are going to have what is given. And in the numerator, we're going to have something that satisfies both conditions, okay? All right, now what is given? Given is that the second disk is red. What's the probability of the second disk being red? Let's look at this tree diagram. When is the second disk red? What are the cases for that? This is one possible case, and this is the second possible case. Do we know their probabilities? For the first case, it will be this path that we are following. First blue and then red. And the second could be red and red. Now, this one we already know. What about the first one? 8 out of 11, 8 out of 12 times, what was this number? 4. 4 out of 11. What does that give us? That gives us 32 divided by 12 and 11. That's 8 out of 33. And that's not a nice way of putting on a calculator. Might confuse you. 8 over 12 times 4 over 11. That's what I'm doing, okay? That gives me 8 over 33. Now, you get the second disk red either in this case or in this case. So any of these two cases is possible, right? So what's the probability of getting the second red disk? It's just the sum of these two. So it's the sum of these two numbers. So you can say probability that second is red. This is equal to 8 over 33 plus 1 over 11. You can see what that turns out to be. 8 over 33 plus 1 over 11. And that gives me 1 over 3. That's the probability of the case that is given. Okay. Then what about the probability of both being red? What's that? Both red, that is 1/11. When both are red, it's obvious that the second is red as well, right? So what about the conditional probability now that they're asking about? What is that probability going to be now? How do we write that? We can say that probability equals, in the denominator, we have what is given. What is given? That the second disk is red. That is the probability of the second being red. That's given. We have that in the denominator here. Okay, so in the denominator, you have what is given. And what about the numerator? In the numerator, you have the case when both conditions are satisfied. Second red and both red. Now, when both are red, of course, the second is also going to be red. So that's 1/11. That's what your numerator is going to be. 1/11. You can simplify this. This is 1/11 divided by 1/3. That becomes multiplied by 3. So that gives you 3/11. That's the probability that they were asking about. This is as complicated as it get in your syllabus. This is the conditional probability that we were looking for. Is that okay? Any problems with this? Any questions on this? Make sense? Okay, now let's have a look at a couple of more questions now on general probability. Now let's look at some slightly more complicated ones when we have more things unknown. Yeah, so let's talk about this now. A bag contains red and blue pegs. Altogether, there are 25 pegs, of which n are red. Rashid picks 2 pegs without replacement. Okay, again, this is without replacement. The tree diagram shows the possible outcomes and their probabilities. So there are 25 pegs in total. So altogether, there are 25 pegs, of which n are red. Okay, now you see 25 is the total, n are red. If n are red and the total is 25, what's the number of blue pegs then? That's 25 minus n, right? So you subtract n from 25. That's what we've got here. Now they're saying complete the tree diagram. Complete the tree diagram. Now, how can we do this? They've already completed this part. Let's focus on the second branch here. This is the probability of taking out a blue ball the first time. Initially, what you have is you have n red balls. And what about the blue balls? The blue balls are 25 minus n. And the total is 25. Okay. If you take out a blue ball the first time, if the first time you take out a blue ball, what's the number of balls after this? When you take out a blue ball, what's the number of balls after this? The number of red balls is still n, right? What about the number of blue balls? You subtract 1 from this. So 25 minus n minus 1. What does that become? That becomes 24 minus n. And what about the total? The total was 25 earlier. The total now becomes 24. So what are these probabilities going to be then? For red, we would have n over 24. And then for blue, it's going to be 24 minus n divided by 24. This is what the tree diagram is going to look like. Now it says, write an expression as a single fraction in terms of n for the probability that Rashid picks a red peg, then a blue peg in that order. Okay. Red peg and then a blue peg. So he has to start from red and then pick a blue peg. Right? Now, what is this probability going to be? You just multiply those two numbers, n over 25 times 25 minus n over 24. It says, write as a single fraction. So now we have to simplify this as well. What do we get when we simplify this? In the numerator, we can get 25n minus n squared. In the denominator, it's 25 times 24. You can see what that is. It will be 480 plus 2600. Let's just confirm this. This is calculator paper 600. This is what you write there. 25n minus n squared divided by 600. That's the probability that you get a red peg and then a blue peg in that order. Now it says the probability that Rashid picks a red peg, then a blue peg in that order is 1 over p. So they're saying that this number that we have calculated above, this is actually 1 over p. Given that the number of red pegs n satisfies this equation, find the value for p. Okay, now that's a 2-mark question, and they're saying the number of red pegs, it satisfies this equation. How do you find the value of p using this? Okay, so what we can do is we can try to solve this equation, find the value of n from that. They're saying it satisfies this equation, the number of red pegs n. We can find the value of n from this equation and see what that turns out to be first. Let's evaluate this. N squared minus 25n plus 150 equals 0. Now we can either use factorization, or if you don't like that, you can put this in the quadratic formula and then write down the answers. Can we factorize this? 30 and 5, will they work? No, we have to subtract in that case. That would not work. 15 and 10. 15 and 10 will work, right? N squared minus 15n minus 10n plus 150. That is going to work. 30 and 5 would not work here because there's a plus sign here, right? So 30 minus 5 gives you 25. That's not going to work. You will not be able to factorize it if you use that. So you need two numbers which when added give you 25. So there are 15 and 10. So we can break it down like this: minus 15n minus 10n plus 150. And now we get n into n minus 15 times minus 10 times n minus 15, n minus 10 times n minus 15, and you get n equal to 10 or n equal to 15. These are the two values of n that we get. That gives you the number of red pegs. Okay. Okay, so that's the number of red pegs. It's either 10 or 15. Okay. Now let's have a look at this. Do they give us any condition for that? Okay. So it's either 15 or 10. Do we know which ones are more, red or blue? Okay, so it could either be 10 right now or it could be 15. It could be any one of these two possible outcomes. Okay, now once we figure this out, what we have to do is we have to figure out the value for p from this. Okay, how can we do that? I'm sorry, what happened there? Sorry, scroll up. Okay. Yeah. So these are the two values of n that we're getting. Now let's see by inputting in this and see what we get. If we input n equal to 10 there, let's see what we get in that case. 25 times 10 minus 10 squared over 600. We put this value of n here. What do we get from that? It's 250 minus 100 divided by 600, which simplifies to 1 over 4. Okay, but what if it was 15? I think that's going to give us a negative result, or maybe not. Let's check. 25 times 15 minus 15 squared divided by 600. Let's see what this gives us. 25 times 15 minus, this is not negative, minus 15 squared divided by 600. Okay, so both of them give you the same result, 1 out of 4. Okay. So n equals 10, n equals 15. Both of those values of n are giving you the same result, 1 over 4, 1 over 4, when we input those values of n in this. They are saying that this probability was supposed to be 1 over p. So what's the value of p then? If it's 1 over p, if 1 over p equals this or equals this, the value of p therefore is going to be 4, right? Because that's what we have in place of p there. So p equals 4, and that's your final result. Okay, so this is how these tree diagram questions are going to work. Now let's have a look at one last question. Oh, so I did not see the next part. We actually did the next parts along with that. We did not really have to solve that equation. We had to show that n satisfies this equation. Okay, so in the next part, actually, they ask you to solve this equation. So that means there is an alternative here as well. So what I'll do is I will paste it here and think of an alternative way of doing this in case I can figure that out. So there might be another way of thinking about this as well then, if they're saying it satisfies this equation. Okay, so another way could be to use what they have said. They have said that this should equal 1 over p. Let's do that. We can say 25n minus n squared divided by 600 equals 1 over p. We could do something like this. And then when we cross multiply, what does that give us? That gives us 25pn minus pn squared equals 600. Now, if n has to satisfy this equation, what we can do is we can rearrange this and try to make it that somehow. This could be another way of thinking about this. Probably it's going to be quicker as well. Let's see what we get when we do that. If I take these terms to the right side, that is going to give me pn squared minus 25 pn plus 600 equal to 0. So this is the equation that I'm getting now from here. Pn squared minus 25 pn plus 600 equals 0. Now they are saying it should satisfy this equation. Now, can we compare these two equations? Not yet. We can't compare them directly because, for now, because this is 150 and this is 600. So first of all, we need the same numbers here. This constant, if this is 600, this should also be 600. Or if that is 150, this should also be 150. Then we can compare the other numbers. We can compare the n squared coefficient or the n coefficient. We can't do that right now. So what we can do is, the given equation, the easier way of doing this would be that we multiply this equation by 4. Let's see what we get when we do that. If we multiply this equation by 4, we get 4n squared minus 100n plus 600 equals 0. And now these constants are matching. If these constants are matching, that means that the other terms should also be the same. So this term should correspond to this term. Minus 25pn should correspond to minus 100n, and 600 already corresponds to 600. So what's the value of p that we get? Pn squared is equal to 4n squared. The value of p that we get from here is also going to be 4. Okay, so this could be another way of thinking about this, because they've asked you to solve this equation in the next part. That means they expected you to do it this way. It doesn't really matter though. Even if you do it the other way that we did before, that also works, because that will give you the answer to the next part as well. And you can just copy that here in the next part then for part 3. For part 4 now, they're saying, given that at the start there are more blue pegs than red pegs, now the values of n that we're getting are 10 and 15. If there are more blue pegs than red pegs, find the probability that Rashid picks 2 red pegs. Okay, now if there are more blue pegs, n is representing the number of red pegs. Now this number could either be 10 or 15, right? These are the two possibilities for n. It could either be 10 or 15. Now, if the number of blue pegs is more, that means the number of red pegs has to be less. So n has to be 10 and not 15, because if n is 15, the number of blue pegs will become less. So n has to be 10. So we can say the value of n that we use then should be 10, right? Because the number of red pegs has to be less and the number of blue pegs has to be more. In that case, what's the probability that Rashid picks 2 red pegs? 2 red pegs. What case is that? That is this case and this case, right? So that part that we have there, if it's 10, we can say this is going to be 10 over 25, right? If n is equal to 10. In that case, we can say 10 over 25 times 10 minus 1, which is 9 over 24. And that should give you the result. Let's write that down here. 10 over 25 times 9 over 24. You can evaluate this and see what that is. It's going to be 90 over 600. Right, which simplifies to 3 over 20. And that's the probability that we were looking for in this part. Does that make sense? No problems? Okay, now let's look at one in which there is no tree diagram. So we've done a number of them in which we have tree diagrams. Let's do a slightly different one. This looks like a good one. You might be able to do this or this. Okay, this does not look that difficult. Okay, let's just do this one. This is the last one that we'll do today. In a game, when it is Mary's turn, she spins each of these fair spinners once. These are fair spinners. Fair spinner means that all the outcomes have equal probabilities. Mary's score for the turn is worked out using the formula xm plus yn, where x is the number on spinner x and y is the number on spinner y. Okay, so how are they calculating the score? So these are fair spinners. She's spinning each of them once. The score is calculated using this formula xm plus yn, where x is the number on spinner x and y is the number on spinner y. The possibility diagram shows Mary's possible scores. Now, on the first spinner, on one spinner, these are the possible outcomes: -4, -1, 3, and 4. That's the y one. And on the spinner x, you have 5, 7, 11, and b. How are they calculating the scores? xm plus yn. That's the formula that they're using for this. So we need to find the probability that Mary's score is less than 15. Okay, now these are the possible scores. How many scores do we have here in total? These are 16 scores in total. What's the probability that the score is less than 15? How many of these numbers are less than 15? Well, there's only one number out of 16, so this probability is 1 over 16. Okay? All right. Calculate the probability that in 2 consecutive terms, Mary scores less than 40 on one and more than 75 on the other. Now, this is a good question because it will clarify one other concept as well. They're saying score is less than 40 on one and more than 75 on the other. Okay, What's the probability of the score being less than 40? Let's figure that out. Less than 40 scores, we have this, these two, and these two. Right, this is where scores are less than 40. What's the total number? 7 out of 16. So less than 40 is going to have a probability of 7 over 16, right? That's less than 40. Okay. And then more than 75, which case is that going to be? More than 75, this number, this number, this number, and that's it. We've got 3 numbers satisfying that condition. So that is going to be 3 out of 16. Okay. 7 out of 16 and 3 out of 16. So there's an and between them, right? When we have and, we multiply probability. So it's going to be 7 over 16 times 3 over 16. All right. Now we can figure out what this turns out to be, but we have to be careful. This is going to give you the probability that the first number you get is less than 40. And then the second number that you get is more than 75. They have not specified that it has to be in this order, right? They've just said that one of the numbers has to be less than 40 and the other has to be more than 75. It could also be in the other way, in the other order. It could also be that the first number is more than 75, so that will be 3 over 16. And then the second number is less than 40, that will be 7 over 16. That's another possibility. So what we have to do is we have to find both of these cases, which are essentially the same, and we add them up, right? So the result is going to be the same from both of them, but we have to consider this probability twice because the order could be different, right? You could have the first number less than 40 and second number more than 75, or we could have the first number more than 75 and the second number less than 40. So we have both of those possibilities. So we have to consider them, consider both of them. This gives us 21 over 16 squared is 256 plus 21 over 256. So we have to add these up, and that should give us the result. 21 over 256 times 2. That's 21 over 128. And that's what we were looking for. 21 over 128. That's the probability that we get here. Okay. Let's move on. The diagram shows 7 on spinner X and -1 on spinner Y. Using the formula, the score for this turn is 7m minus n equals 38. Using the table, find 7m plus 3n. Okay, now how do we think about this? The diagram shows 7 on spinner X, 7 on spinner X, and -1 on spinner Y, -1 on spinner Y. So what you do is you do 7m minus n, because the score formula that they've given is xm plus yn, right? That's the formula that they have, xm plus yn. So in place of x, they're inputting 7. So that becomes 7m. In place of y, they're inputting -1. That becomes -n. And that gives you 38. Using the table, they're saying find 7m plus 3n. What that means is use the table to find where x is 7 and y is 3. What is the score in that case? When x is 7 and y is 3, use the table to find the score. x7, y3. Okay, so x is 7 and y is 3. What's the score in this case? 26. So that means 7m plus 3n should equal 26. This answer is 26. Okay, because x by m plus y, and that was giving you the score. If you input those values of x and y there, the score is actually given on this diagram. That's 26. And now they're saying, hence find m and n. We have to find the values of m and n using this now. We have 2 equations in terms of m and n. 7m minus n equals 38, 7m plus 3n equals 26. We can solve them simultaneously, find the values of m and n. 7m minus n equals 38, 7m plus 3n equals 6. You can use substitution, elimination, whichever method you prefer. In this case, elimination is going to be fairly quick because we have 7 and 7 in both of them. So what I can do is I can say, let's subtract the second equation from the first. So we can change these signs then. This gets cancelled, and we have minus 4n, minus n minus 3n, right? That's minus 4n equals 38 minus 26, which is 12, and n equals minus 3. Put this value of n back in any one of those two equations. If I put that in the first one, that gives me 7m minus 3 equal to 38. So 7m plus 3 equals 38, 7 equals 35, and the value of m turns out to be 5 from this. So m equals 5 and n equals minus 3. That's the result that we get from this. And then they're saying find the value for p. So now that we know that score is calculated like this, xm plus yn, right? Xm plus yn, that is the score. Okay. What's p? So let me actually input the values of m and n here as well. M is equal to 5, so that becomes 5x. N is equal to minus 3, it becomes minus 3y. This is how the score is going to be calculated. Okay. What was p? P was actually one missing number on this diagram. That was this number here. Okay. It's the value of x. They are saying find this value of x somehow. Now you can use any of these numbers. For example, if I use any number below p, I can use, for instance, 73, let's say. 73 score is what I get when y is 4 and x is p, right? The score is 73 when x is p and y is 4. So what I can do is I can say put x equal to p, y equal to 4. In this case, the score is equal to 73. And that gives me 73 equal to 5 times p minus 3 times 4. And we can find the value of p from this. 5p equals 73 plus 12, which is going to be 85. And the value of p turns out to be 85 over 5, which is 17. So p equals 17. That is what we were looking for here. Make sense? Any problems with this? Any questions? No? All right, good. So that's it for today then. I hope this was helpful. I'll be uploading this probability worksheet as well now. You can write some more questions from this, and then we start our next topic on Monday, inshallah. All right, so please make sure to complete the previous worksheets. Let me know if you have any problems. Fatma, I'll respond to you. It was just a completing square question that you sent, but I will explain that in writing there as well. But that's it for today. I'll see you again in the next class. Allah Hafiz.